Well, I'd like to begin by thanking Masood for the invitation and also for, again, acknowledging his, you can see that all right? Screen's good?
Yes, yes.
Yeah, thank Masood for the invitation and also for the the work he's put in trying to get everyone together and to share data across the world, because I think this is the way to go in the future. Right, so what I'm going to share today is firstly an overview of the large-scale studies characterizing sleep across the world, why we do it, and talk about one particular data set that we've gathered in conjunction with Aura. So we have independent say about how we want to shape the narrative, but Aura Health kindly provided information, and I acknowledge them at the end. Now, we are at this talk because we are interested in sleep, and we acknowledge that it has got very material effects. And for this group, mental health, behavioral health, and cognitive health are of paramount importance. Now, underlying these outcomes, right, are factors that affect, that modulate sleep, that act on, hang on, let me get this right. That act at the individual level, at the social level with our interactions with different people that are around us, as well as at societal level on a much broader platform. And this work is related to this interest in relating these two worlds. Now, sleep is a multi-dimensional construct. And it comprises duration, efficiency, timing, alertness, satisfaction, as well as regularity. However, for the most part, discussions about sleep center around duration because this is easily understood. It is the dimension we have the most data on, and this has allowed us to create a preliminary age group specific recommendations. When I say we, it's the American National Sleep Foundation, actually. Now, it's recently emerged that regularity is also a big factor influencing sleep health, but regularity has to be, for it to be studied well, there needs to be reliable long-run data. And this is something that's difficult to acquire prior to the emergence of wearable technologies and well-designed apps that are quite widely disseminated. Now, underlying any recommendations that we make to our constituents is solid data. Now, with regard to the NSF recommendations, which have been mirrored in other countries' recommendations, these are now 8 years old, and they are very respected. But the sleep was mostly assessed or evaluated, all the data, the sleep was assessed by a questionnaire in over 90% of the studies that entered the discussion. Further, the term sleep refers mostly to time in bed allocated to sleeping and rather total sleep time, which I believe you can accurately measure with wearable technologies today. And in the future, people will be thinking of both the time they spend in bed and the time they actually are asleep. Now, most of the data also comes from North America and Northwestern Europe, which constitutes only about 25% of the total human population. So while the sleep scientists in these territories are very influential and been thought leading, the data and the information is actually quite circumscribed. So this leads us to the point about why study sleep patterns around the world using objective tools. Now, the first thing, of course, is that we like to make comparisons. It's just human, we compare kids, we compare, various aspects of our lives, and sleep is no different. We like to know where we stand in relation to others. But to make accurate comparisons and to be able to create more accurate sleep norms, we want to try to collect objective data. Now, work done by Jennifer Gershuk and others in Australia have shown that when you compare self-reported sleep, which is where most data comes from actigraphy, the agreement is can be quite low, right? Further, as I've alluded to earlier, we have contributed work showing that if you want to have reliable estimation of sleep variability, you need a minimum number of nights that's more than what most studies currently provide. So if it's a 1 week estimate, you need about 5 nights. And if it's a 1 month estimate of variability, you need about as much as 20 nights. So this would not have been possible before the advent of quite reliable sleep tracking with wearables. Now, for wearables to be widely disseminated, they have to have a certain quality. And in the early days, there were questions about the reliability of consumer sleep technology. But now I think some of you in the audience are also beginning to use this in your research because you realize that you can collect data on scale with enough reliability to make responsible inferences. So things are changing, and we need to get a global perspective. Why? The second reason we want to do this research is to differentiate between biological, environmental, and societal influences. So examples of biological influences are your chronobiology, your proclivity to sleep earlier or later, with your chronotype, as well as age. And we know that there are developmental changes in sleep as you get through the lifespan. There's also environmental factors, for example, light exposure, differential light exposure, timing of light exposure, and sensitivity to light. And versus, it's like culture, the prevailing, say, work or the sports culture, they influence your sleep when you eat, etc. And also how we interact with our peers in the social environment, something very relevant in the age of social media. So how to differentiate these influences. Now, to date, a lot of the large-scale studies performed have collected a lot of data, and this is a brilliant study, and I will acknowledge here that they are probably the most complete single study using wearables by Jonas Dotter. And these studies tend to look at data from different societies and countries, but the goal is to formulate generalized principles or predictive models about sleep in general across the world. So another example is this work that's gained a lot of attention in the press by Kotruth and Hugo Spiers. Also, which had quite a lot of phenotype information. And the desire in these large studies is to model complex behaviors and try to make unified models, right? For example, the two-process model for sleep is an experiential model which accounts for some of the variants, but not all the variants. Another point I want to say here, in terms of discerning or this approaches to the availability of diverse information, is that sleep science is heavily influenced by researchers based in Western educated, industrialized, rich and democratic countries. And you can see here in the number of editors from weird countries, over 90% of them are from such countries, and they have formulated all the theories that we have, the influential theories, and this does come through some filters based on what they are used to and what they're exposed to. Which brings me to the third point, is that in order to provide sleep advice or interventions that are acceptable to different cultures, we need to look at some of the differences and what drive these differences beyond just looking at the general principles that unify different societies. So I want to say at this point that there are unconscious biases in selecting models when working with high-dimensional data. And this is an example I picked up from HR manual. I mean, to suggest that there are unconscious biases. I mean, people are not aware of them until it's clearly pointed out. And I'm going to give you some examples with regard to sleep. So as we know, Matt Walker is about the most famous sleep scientist on the planet because of his efforts, in his book, as well as the many podcasts that he's given. And one of the master classes on sleep he's given, which is spread worldwide, is that if you want to sleep well, you should take a warm bath before you go to sleep. Now, this is certainly relevant if you are living in the extreme latitudes where the climate's cooler. But if you're in the tropics and the ambient temperature is 35 or above, it's very difficult to take this advice. Similarly, if we adhere to the advice given by the National Sleep Foundation to cool your room or to keep the room at about 20 degrees Celsius, people living, say, in India or in even in Singapore would expend a lot more energy and contribute much more to the carbon footprint, if they cool to that temperature. So along this line, some efforts are being made. For example, this is work done by a Saudi group that is making some affordances for how people in Saudi Arabia who have to wake up in dawn to make prayers, and how to sleep during the fasting month, how to make accommodations for that. So there are efforts using science to make principled recommendations about sleep. Now, looking at some of the main findings of the large-scale cross-country sleep samples to date, I've categorized the quality of evidence as sample independent, which means the results are quite generalizable, sample dependent, and then situations where there are gaps in the data, either in the data or their interpretation. And I'm going to go through the green and yellow bits. And the reason that I'm presenting our data is because we focus on regularity and efficiency, which have from a different perspective. And you'll hear that in shortly. Now, as far as sex effects on sleep duration goes, I mean, I think it's universally agreed that women sleep objectively better than men. Now, they have more subjective complaints about sleep, but they generally sleep longer than men of the same age, right through the lifespan. So this data from 5 countries that Julian Ong from my lab collected using data provided by Fitbit. This is the work I've already mentioned by Jonas' daughter, where she had access to data from Sony across multiple countries. And you can see that the women coded in red, sleep a lot more than the men, right? And then from a web app, you can see this is from Oliver Watch data. And of course, this is the work that I highlighted from Cotrud that shows also a very strong gender effect. Now, with age, the effects on nighttime sleep duration are quite agreed on earlier in life, although the exact durations might vary from society to society, but generally there's this decrease in sleep duration, and then a sharp shoulder around adolescence, and then fairly stable. The question mark is around the retirement age, where, in this work by Rothwag, which is very influential, 1996, is taught in all sleep courses. There is a slight decline in sleep in one's senior years. Now, this data is sample dependent. In our own data collection by Julian Ong, you can see that both for in the Oceanian countries as well as Asia, there is a slight uptick in the weekday sleep duration in the post-retirement years amongst the Fitbit users. You can see a little hint of this, although the curve is much flatter in the Jonas' daughter work as well for the weekday sleep, but not the weekend sleep. And then in the single question-based Sea Hero Quest game by Cotrud, you can see that there is an increase in sleep in the post-retirement years. Now, these findings from large-scale studies were actually antedated by work done from epidemiological studies. For example, this one by Erica Hagen, showing that in Americans in the post-retirement years, the retirees who responded to the survey were able to report better weekday sleep duration, just like we showed earlier. And then this work by Dr. Ackerstedt from Sweden found that if individuals have, older individuals have catch-up sleep on the weekends compared to those who don't, they tend to do better. But this predicates on having a certain status in society, a position in society where you can retire comfortably. And the situation may be different. Like in this worker in Singapore, is way past 70 and he's still having to work hard, sweep the streets and clean the streets. And he might not have the luxury of sleeping in on weekdays if he can retire at all. So just to summarize some of the large-scale wearable and app-based sleep studies that are done to date, I've highlighted in blue those that involve devices that are consumer technology. And then the app-based or question-based studies are in yellow. Now, in the data I'm going to present, we try to fill some of the gaps not covered by the knowledge generated by these studies. The Jonas-Dotter, as I've mentioned several times already, is a very comprehensive study on a good number of persons of median working age group. Now they characterize the effects of age, gender, but the sleep variability, although mentioned, was not analyzed in detail, and no reasons were proposed for why some of the differences were observed. Koala study was also multiple countries. I believe it was close to 80 countries, but it focused on young adults and the developmental trajectory of sleep duration in these younger adults across different countries. Ong Julin's study comparing 3 Asian countries and 2 Australasian countries is limited in its reach in terms of countries. And then the others have some other different limitations. The Jonas-Dotter 2022 study was focused on examining the effects of travel on sleep. The minor study from the same group focused on temperature effects across countries. And then, the Sea Hero Quest study was based on a single question on sleep, and it didn't make any differentiation between weekdays and weekends. Okay, I'm just going to pause here. Are there any questions? Just feel free to interrupt me. Okay. The work that I'm going to talk about for the rest of the talk is related to country difference in nocturnal sleep variability, observations from data we collected from Aura Health, which they provided anonymized de-identified data. Now the objects of the study, I put in gray because we just wanted to re-explore some of the effects of sex, age, and country on duration and timing. These have been established before. We just checking to see whether they can be replicated or whether we see something different. We also evaluated differences in sleep efficiency. We sought to clarify the weekend sleep differences across 35 different countries, framing in terms of weekend sleep extension and social jet lag. And finally, we characterized weekday sleep variability because that's the time most of us spend working. So here are some of the characteristics of that data set. We had about over 220,000 unique Oura Ring users from 35 countries. Over 54 million nights of data were available. And this was translated to an average of 242 nights per user on average. For weekday night assessment, they had to supply at least 4 weekday nights to be assessed, and they had to have both weekend nights. Now, the importance and the value of this study is that the large number of nights per person allowed us to get accurate individual information about sleep duration and the weekday, weekend differences in sleep patterns as well as sleep variability. Now, this duration of collection, which is over a year, is important because it varies some of the seasonal effects on sleep that may be present, especially in higher latitudes, if only a 6-month or shorter window is obtained. And that's true of many of the previous studies. Now, every wearable that you wear, and this is true of what the critics say, has edge cases where sleep is inaccurately detected. For example, the device can say that you were sleeping despite the fact that you were lying very still with a slow heart rate when in bed awake. Most healthy people have a few of such nights, but when you collect so many nights, this is sort of buried within the mass of data you have. We were also careful to ensure that each country that we were included in the sample had enough people, at least 200 people across the lifespan who wear the product, right? And then we were also careful to exclude periods of transmeridian travel because we wanted to establish the habitual sleep for the individual and not look at effects of real jet lag. Weekend nights, for reference, refers to sleep on Friday or Saturday nights for the rest of the world except the United Arab Emirates, UAE, where the weekend nights were taken to be the Thursday or Friday nights. Now, this was the main statistical model, a multiple regression model, which included sex, a linear term for age, a quadratic term for age, the day type, which separated weekday and weekends, the country, and then various interactions between these terms. This is the geographic coverage, and you can see it is not totally global. What is clearly characteristic of data, there are a lot of North American users, a lot of European users, as we can expect from the nature of this kind of product. And with Asia, we have representative samples, but they're not like massive numbers. We have Africa is very marginally represented. Oceania is well represented, but there's no representation from South America. Now, this I wouldn't say characteristic, but this uneven coverage of the world is also seen in previous study. This is the one done by Kotrude. Now, here the density of the color, we added a layer of transparency. So if the color is not solid blue, the density of sampling is relatively lower. Although the absolute numbers may still be high in these countries, right? So that's Kotrude, that's Jonas Dotter, Koala, and you can see that in general Africa is not well represented at all, in South America variably. So now on to our data. Now, the other thing I want to say is that wearable users are somewhat privileged. They belong to a higher socioeconomic status. So we really don't know how the average shift worker or laborer sleeps. And that is a limitation of actually all these studies. Okay. Now, in terms of sleep duration across countries, we replicated some of the key findings in previous studies. There was about a 50-minute spread between continental or country differences in weekday total sleep time, with the Europeans having the longest sleep time and Asians the least, and the Americans sort of intermediate. Right, and then in terms of the origin for these differences in sleep time, you can see that it's related to the weekday sleep timing, and that countries with a later bedtime generally were, like for example in Asia, were the ones with the shorter sleep duration, and that's because wake times are relatively more similar across countries. Two notable exceptions that I want to point out are South Africa, which has very early bedtimes and very early wake times, and Russia, which has very, very late bed times and wake times down here, Russia here, right? Oh, you can't see that here. I don't know if you can see can you see my cursor? Can you see my cursor?
Yes, yes.
Yes, yes.
Okay. Oh, right. All right. And then there was a shallow linear age effect, so no quadratic effect. So the older people, we didn't have very many old people, but the older people, didn't show this uptick in sleep duration. There was a very, very clear effect on sex. Now, this is the data plotted by continents, and you can see that the countries with a shorter total sleep time were those that have a later sleep onset. This is very quite clear from this. And the total sleep time spread was 55 minutes from this here to here, but that the bedtime spread is almost twice that. It's 100 minutes. Okay, and here I want to say something about sleep duration, because one of the things that people will ask is, all right, there are these clear differences in sleep duration, and you mentioned that, I mentioned that, they're quite, we took data over a long time per person. So is it that these Asians have a lower sleep need, and Caucasians living in Oceania or Europe tend to have a longer sleep need? I just want to say that this is unlikely to be so. This is a meta-analysis not meta-analysis, an aggregate analysis of 35 studies done from independent countries about nighttime sleep duration and all-cause mortality, as well as the 24-hour sleep duration and all-cause mortality. And you can see that the curves sort of agree, they sort of bend at the 6+ hour mark for nighttime sleep duration, and slightly longer for 24-hour sleep duration. So we think that right now, the present knowledge suggests that there are no strong genetic differences in amongst ethnicities in sleep need. This can also be seen in the effects of cognition, the optimal sleep duration for cognition, and this is work done by C.J. Wild reported some years ago with 16 cognitive tests, but these were the top tests, and you can see that the optimal sleep duration is just around the 7-hour plus mark. Okay, and I would emphasize that this is time in bed rather than TST. Now, I mentioned this to be the segue for the next part. Ideally we want to spend the time in bed efficiently. We want to spend the time we allocate to sleep in sleeping. But you can see that sleep efficiency measured by consumer wearables does have about a 3-point spread across the country's sample. Now, 3 points does not seem a lot, but it's a very consistent difference across countries. You see the error bars are quite small, and that surprisingly, the countries with shorter sleep, you would expect higher sleep efficiency, right? Because you're having short sleep, you expect them to come to sleep pressure and to sleep more, but actually we saw the reverse. We don't really know why this is so, but it's a pretty clear finding. Now, where's this difference in sleep efficiency coming from? Now, sleep latencies were an average of about 11 minutes, and the spread was just 1 minute across all the different countries. So that's not the source. The difference in sleep efficiency actually came from wake after sleep onset of WASO. But even this was quite closely grouped between 41 and 48 minutes. Right. Now, the other topic that we covered was the point about weekend sleep extension versus social jet lag, and I want to explain these terms, right? So in this bar graph, you can see bedtime, and then wake time, and then the mid sleep time, right? And this is on a weekday, and on the weekend, you can see that there's one common pattern where people sleep a little later, but they wake up quite a bit later. So this results in sleep extension, and this is this bar is the same length as the weekend sleep time, but projected to start at the same origin as the bedtime on weekdays. Now, the shift in mid sleep time, and this is a shift whereas this one is a duration. The shift in mid-sleep time is quantified as the social jet lag. And this particular pattern of positive correlation between the magnitude of sleep extension and the shift in social jet lag is commonly seen in European countries, right? So Finland is a top example here. Not every country is the same. There are countries like Thailand, an Asian country with less weekend sleep extension and minimal social jet lag, right? Minimal social jet lag. And then there are exceptions. Now, although this is not seen in aggregate in our data, it was seen in the Japanese data, which I share with you later. These are countries with no weekend sleep extension and negative social jet lag because they actually wake up early on the weekends. So 30% of a study in China, the sample showed negative so jet lag. And also this was also observed amongst bird watchers in Germany, and they have to wake up early to catch the bird, so to speak. And they have negative social jet lag, but this is it's not common in Europe, but it is seen in quite a bit in Asia. So when we rank countries based on weekend sleep extension, you can see that the Europeans, again, handily, trump the Asians by a fair margin, almost 2.5 times, over 2 times as much weekend sleep extension, right? With the US, Canada, and Oceania being intermediate. Now, when you look at the different ranking, if you look at weekday total sleep time and you compare that with weekend sleep extension, what you notice is that at the country level, the countries with fairly short sleep duration don't have disproportionately more weekend sleep extension, and that's it's a bit of a surprise, right? However, when you look at the regression model, which takes into account individuals, regression model does show that individuals overall show a negative correlation between weekday total sleep time and weekend sleep extension. So this sort of affirms that there is some component of catch-up sleep in this weekend sleep extension. However, the significant country effect was also present, and this is abundantly evident from the bar plots. Right. Now, this slide is not our data, but it points out the need to re-examine the idea that weekend sleep extension is about catch-up sleep. It is there, and we showed that there is some component of weekend catch-up sleep, but there's also either a social or cultural element to extending sleep on weekends. Now, COVID provided one of the largest natural experiment on sleep, and this data collected from 31 samples in multiple countries found that overall, during COVID, people slept later, woke up even later, so they had more sleep time on average, right? But critically, the time in bed, right? There was more time in bed during the week and no change in time in bed over the weekend, and where you expect it to go down, right? So if the sleep extension is for catch-up sleep, then you expect the weekend time in bed to go down, but it didn't, right? So this suggests that there are also social cultural factors that go into why there is weekend sleep extension of the magnitude you see in Europe. Now, when you put the weekend sleep extension, weekend total sleep time, and social jet lag, you find that at the individual level, the regression model shows there is a positive association between sleep extension and social jet lag, but there's also a country effect, so that at the country level, the correlation is much less evident, right? So the point I want to emphasize and make clear in the red colors is that the shift in sleep timing associated with social jet lag and sleep extension are not interchangeable. The lay public tends to conflate these terms, and it's not right. And Till Ronenberg, the originator of the term social jet lag, also is very emphatic about this, right? Social jet lag is also a construct that has the strongest meaning for European countries, where the there's the strongest correlation between the shift in associated with social jet lag and weekend sleep extension. So just to remind, the original construct of social jet lag was to emphasize the situation where there's a misalignment of biological and social time, and it's predicated on the notion that there are work days where people have to do some sleep because of social obligations of work, and there are free days where they are free. But are weekends totally free? And no, they're probably not in different societies, right? So this point has to be taken into consideration. The fourth major point we're talking about is sleep variability. And here, the sleep variability is taken as the standard deviation of sleep across a week. And we average this standard deviation of sleep variability across the weekdays, over the multiple weeks we have for each individual, and then we derive this plot. And what you can see here is that, interestingly, the countries which have longer sleep actually have lower sleep variability. Now, this is mathematically, somewhat paradoxical or unexpected, because you expect the variance to scale with the magnitude of the measure. So you expect higher sleep variability with longer sleep time, but actually, it's not, in the case what we found is that the variability is higher with countries with a shorter sleep duration. And not only that, along this axis, you can see there is also greater variance amongst the people within that country in terms of sleep variability. So not only is the sleep on the average more variable, it's also more variable across the people in that country, right? So this is an interesting point to raise. And this is the inset, for the mainly the European countries, Oceania, and South Africa. Okay, so this is sort of the last main data slide I'm going to make, is that these are the countries ranked in terms of weekday sleep variability. And you can see that, again, here it's less clear that the Asians are completely higher, because there are countries like Russia which also have high sleep variability. But what is common across the countries is that weekday bedtime is more variable than weekday wake time. And if you want to target improvement in sleep variability, that's the point to target for, having more consistent bedtime. Okay, so this is the interesting part. Now, how do we explain these findings? The main findings being that I'm going to try to explain are the sleep duration differences and the sleep variability differences. Now, again, I mentioned that one question we get asked is, okay, isn't it genes, right? So this is a study that was performed by Chung, comparing Japanese living in Japan, a number of Japanese, but Asian Canadians and European Canadians, right? And I just want to put this out of the way because it is confusing. The alphabet that is not A refers to as a figure which was statistically different from the numbers that were denoted by the superscript A. So you can see that the Japanese, in terms of objective sleep duration, had shorter sleep than their Asian Canadian or European Canadian counterparts, and that this was not significantly different, but this was significantly lower. And this indicates that the effect on sleep duration is not likely to be genetic, it's influenced by more where you stay. However, there remains a cultural influence because if you look at napping behavior, and those of you living in Europe and North America know that napping until recently is quite frowned on, so it's not common, and the napping is shorter than people with an Asian origin who nap considerably more, right? A very important point driving the shorter sleep is the cultural ideal for sleep, right? It's quite a bit shorter amongst the Japanese compared to the European Canadians and the Asian Canadians, right? And that there is, people have an ideal of sleep which is longer than, which is longer than what they can actually realize, right? And this is like this could be driven by the fact that the perceived relationship of sleep and health is the positive relationship is lower amongst the Asians living in Asia, right, compared to the European Canadians or the Asian Canadians. Yeah, so that last point, relates to the notion that sleep is important, but it competes for time with a lot of other activities, and that list of other activities is growing, but still the king of the mountain is work, right? And this is data collected from the American Time Use Survey by Matthias Basner several years ago. And the plots here show that the more hours you spend on activity, so here the red line is work, as the dominant line is the one with the steepest gradient. The more time you spend on work, the less time you spend asleep. And this gradient is, of course, it's equally strong on weekdays and weekends, right? So weekends, other activities come in, but on weekdays, work is the dominant activity. And our proposition is that a difference in work culture and attitudes to sleep can drive, the differences in sleep duration. Now, this is the time use study from a specific country, but when you look at the overall data, the annual working hours per worker, right, what you see is that the data is broadly in line with this hypothesis, right? The Scandinavian countries, which sleep, quite a lot, and the Northern European countries, they generally have lower work hours than those in East and Southeast Asia, many hours. But there are a couple of exceptions. So Japan here is rated as having, fairly modest working hours. But those of you who know, Japan know that in some cases, these official labor data do not accurately depict actual work hours, right? So in Japan, for example, and this is from a website written by expatriate, you're expected to, take pretty long commutes. The meetings are very long, and after official work hours, you're supposed to go, for meals with co-workers. So this is not directly work, but it does take more work hours. And then the Japanese also have a very famous term, karoshi, or death from overwork, which is the antecedent of another term, the 996 culture, which is China's version of the hustle culture. And these are articles in the New York Times, which point to, the very strong like work culture in China, which is not reflected in some of the data that's collected in these large-scale studies. Right? So we believe that the work culture is and the cultural beliefs about value of sleep are two of the dominant features that are driving some of the differences in the sleep duration. We don't have a ready answer for why the sleep efficiency is lower. Could be, again, it's convenient to say it's anxiety about work or such. But we don't have that direct evidence. Now, this kind of surmise, we understand, is a bit of a leap, but so is the point that latitude is a driving factor for sleep duration. So this is data collected by Kotrut and Hugo Spire's group from that single questionnaire about sleep. And the regression line, this plot here suggests that there is a latitude effect. But I want to point out that if you take the data in a different context and you look at the distribution of the countries, you'll find that Asian and Latin American countries who are in the tropical zone, who have a somewhat different culture, don't go past this latitude, right, which is further north, and where the European countries and even New Zealand lie. All right. And if you took an ellipsoid, you can see that across a broad swathe of latitudes, people have equivalent sleep duration. So I think this comment is interesting. It's a speculation, but it shows, I think, a bit of some, we don't agree with this finding. Now, there's another study, single country across big latitudes, not much difference in longitude. Technically, this study would validate this point about latitude and sleep duration, but the researchers, the authors themselves admitted that difference in photopic period could contribute to some of the found effects. So we think that rather than latitude, it just happens that the Asian countries who sleep less tend to be, closer to the equator, and this is the driving factor. We think the culture is driving the short sleep. Now, to somewhat make that point and to make some other minor points, this is the last data slide I'm going to show. We chose Japan and Finland for comparison. So Japan and Singapore have like short sleep durations. One is like average about 37 degrees north. Finland is of course like at least closer to 60 degrees north of the equator. And if you compare these two countries, you can see that in terms of this box here, in terms of sleep variability, Japan is not only higher in sleep variability, the mean, the standard deviation of sleep variability is higher. In terms of the weekday sleep onset timing, but also the variance is higher. So the individual people, as I mentioned, have they can have either very little variability or a lot more variability, but overall they have a lot more variability, right? So not only is the mean variable, within population, it's also higher. And then, as mentioned earlier, with the data from China, the total sleep time is not always longer at the weekend for the Japanese, and you can see much more than Finland. They tend to have some negative social jet lag. So this is to again add some evidence to the point that it's not just about latitude. There's something else going on. So in summary, I just want to say that the findings of the Willoughby et al. Study are that we confirm that shorter sleep is mostly a result of sleeping later, that Asian countries with short sleep are also those where sleep efficiency is lower. We don't know the reason why. Weekend sleep extension definitely is a cultural element. These differences are larger in Europe than in Asia as polar elements. And that the concept of social jet lag needs to be contextualized. It's the shift is what it is, but it needs to be contextualized for different societies. And finally, weekday sleep variability is higher in Asia than in weird countries, and that we posit that differences in work culture or culture in general is a plausible factor, and that one of the explanations advanced that it's related to latitude is less likely in our estimation. However, these observations stand, but their implications on health and well-being are not clear at present, and they await further data. So I'd like to post our study as a detailed observation, a careful observation. Are we correct in our hypothesis? Time will tell, and other data will tell. There are definitely gaps that we feel. As I showed you from the maps, there needs to be data from a broader range of countries. Just as smartphones became more widely adopted across the world, I believe that sleep trackers will be more widely adopted in time to come. And it will include persons of lower socioeconomic status whom we need to understand so that we can help, because they tend to have poorer sleep. We need to evaluate the contribution of napping and biphasic sleep patterns. As we know, in Europe, naps are not common in working adults. They're more common in kids and older retired adults. But we need to understand, like for example, in the Middle East, there's biphasic and polyphasic sleep patterns. There needs to be a broader consideration of social factors influencing sleep. I mentioned work here, but there are other considerations like different allocations for leisure or for commuting that need to be considered. There's also differential sensitivity to environmental disruptors of sleep across people, and the one that comes to mind is light. It's a very prominent, it's the main thing that's driving our circadian clocks. So differential sensitivity to light is an interesting thought. And then finally, it's very important, and this is our raison d'etre really, is that if we just characterize sleep but had no impact on mental health, well-being, or cognitive performance, then sleep wouldn't matter. But it does impact this, and we need better correlations or association studies across countries, and to allow us to build better models. Now that basically brings me to the end of the talk. It just remains to thank our lovely group that has been, we have a really great group. If you want to find out more about research, just scan this QR code. And I would like to acknowledge our funders, the School of Medicine, as well as the National Medical Research Council of Singapore. And of course, the big kahuna in the room is Aura, who provided the data without which we won't have a study. So with 10 minutes left, I'm happy to take some questions.